Right, so we did limit with, let me turn it off, with x approaching infinity. So let's do a limit with x approaching negative infinity. So we have a limit. Hold on. So limit with x approaching negative infinity. And yeah, we have that. Let me write that original function. So 3x, and then we have x squared plus 2, square root of that. And yeah, just like before, right, we can factor that x squared out, and we'll end up with 3x. And then here we have, right, we had x squared, this is x squared, right, that 2, right, after I factor the x squared out, it becomes 2 over x squared, and it approaches 0, so we can basically ignore it. And at this point, what I'll do, or what we can do is just take this infinity, or large negative numbers, or negative or very small numbers, and plug them in, right? So I would take that negative infinity, right, and just kind of plug it in here. So if we do that, this will become negative infinity, right? And then here I take that negative large numbers, right? So here I'm looking at this, right? Large negative numbers, plug them in there, but then you square them, right? So from negative infinity it becomes positive infinity. So this actually is positive infinity. So infinity. And then, right, so we have that negative infinity divided by the same number, right, but positive infinity. So that will leave us with just a negative number, or negative 1. And then negative 1, and then we have that 3 here, right? So you have 3, so it actually ends up being negative 3. Okay, so yeah, let's look at the graph. Okay, so we have those two asymptotes, positive 3 and negative 3. So this is 3, negative 3, and the graph is between them, right? So it passes through the origin and then gets closer, right, to those asymptotes here and there. Okay. Yeah, so that basically is it. I want to do a couple more things though. So let's just do a couple. Let's try to answer a couple questions. So something that you guys can think about. So the first one is, let's say you have a function. So you have a function f of x, and don't know what that function is, right? So let's just write y. But we know that f of 2 equals 4. So what can you tell, or what is the limit? Maybe let me rephrase. What can you tell about the limit? So what is the limit as x approaches 2? What can you tell about the limit? Where x approaches 2. Okay, so that's kind of the question that I would ask you, right? Just kind of to check for understanding. So I'll give you an answer in a moment. How about if we reverted this question? So if the limit of the same function or, well, the same function. We don't know what that function is, right? As x approaches 2 is 4. So what can you tell maybe about the value at 2? The value of the function, right, at 2. F of 2 is what? Value at 2. Okay, so think about this one as well, and question number 3. How many vertical asymptotes can we have? Is there a limit? Vertical asymptotes can we have? It's pretty bad handwriting, but I hope you can read it. Number 4, how many horizontal? Okay. Yeah, so let's think about it. Let's try to answer number 1. Number 1 was the question was if the value of a function is 4. So question number 1, right? So if f of 2 is 4, f of 2 equals 4, limit x approaching 2, f of x. Right? Do we know what that limit is? Right? So, well, the answer is no, we don't know, right? So the question is, what do we know, right, about the limit? Well, we know nothing, right? So the answer is nothing. Well, why is that? Well, imagine that we have some function. Let's say here's the graph of it, right? So it goes like this maybe, but then as we get to 2, right, I know that f of 2 is 4. Well, 4 is right there, and then the function continues, right? So even though we know that the value of the function at 2 is 4, right? So this is, let me make it better, the graph. So I'm just gonna extend the y-axis a little bit. Okay, so this is 4, this is 2. But, right, even though we know that the value of the function is at 2, right, is 4, and we don't know what that limit is, right? The limit, we would find the limit here, right? So that would be the limit right there, right? As x is approaching 2, right? Not when it is 2, right? So we don't know what that value is, right? So we put, so we can say nothing about about the limit. And the same, right, with the same with the second question, it's similar. We can even use the same drawing, right? So if we know what the limit is, right? So limit, or actually let me make a different drawing, right? So let's say so now we know that the limit, we know the limit. If the limit is x is 4, so let's Right, so let's draw another function. So, okay, it could be something like this. And then, so this is my 2. This is 4. Okay, so you see what's happening. So limit, right, at 2, or as x approaching 2, is 4. Right? But the actual value of the function is -1. Right? So we don't know, we simply don't know what that value is, right? So let me make it just kind of, it's not really 1, -1, right? It's lower than that. So we don't know what that value is. We know that the limit is 4, but the value we simply don't know. Okay, then problem number 3, the question number 3 was, how many vertical asymptotes can we have, right? So we just saw tangent function, and tangent function has infinite number of vertical asymptotes. So infinite number. Okay, so that was number 3. Number 4. Is that infinite as well? Well, not really, right? So we can have 0 horizontal asymptote, 1 horizontal asymptote, or 2. Okay, because we cannot have more, because we have positive infinity and negative infinity, right? We don't have a third option. And yeah, we just saw a function somewhere, right, in the previous example that had 2, and then there's like rational and irrational function, like the simplest one, 1 over x would have 1, right? And parabola doesn't have any asymptotes, horizontal or vertical. Okay. So I'd like to give you more examples and problems on finding limits analytically. So let me write it here. So finding limits analytically. Okay. Yeah, so what is this about? It's about those the first topic when we talked this 2.4, when we talked about the infinite limits, not limits at infinity, but infinite limits. So I want to just give you more examples and a couple points. So let's look at maybe something like this. So we need to figure out the limit with x approaching 0 from the right. Okay, and the function picks something simple. 5 plus x over x. All right. 0. Okay, so let's start with just showing you the situation on the number line. Okay, so this is a number line. This is 0. This would be -1, and this is +1. Okay, so what's happening? We're approaching that 0 from the right. Okay, so this is what's happening. We're getting closer to 0. The mistakes that students sometimes make, right? They would take numbers and plug them in, right? So this is the question is, well, is this gonna be positive infinity or negative infinity, right? So this is gonna be infinity, positive infinity or negative, right? So the way to solve it is basically just plugging in a couple numbers from that region, right? When we get close from the couple numbers that are close to 0. But the mistakes I see students make is that they would plug in, numbers like 2, 3, right? Which technically should be correct, but these are not numbers close to 0. Okay, so maybe we can plug in 0.5, right? Maybe we can plug in something maybe even closer, right? So let's start with like 0 point, 0 point, not negative, make it blue. So 0.25 and see what happens. Okay, and then we'll plug in 0.1. Okay, so if I take 0.1, or let me just say one thing, right? So you cannot take, and you obviously cannot take 0 and plug it in the denominator, right? Because that would give you 0 in the denominator. But, well, you can plug in that 0 in the numerator, right? So if we do that, what I'll get in the top is 5, right? So 5, and then I have that 0.25, right? That's my first number, 0.25. So if we divide it, I'm getting, what is it, maybe 20? I don't have a calculator. Okay, so we have that. Because I'm dividing by 1/4, so it's multiplying by 4. Okay, so let me erase this. All right, so I plugged in that yeah, 1/4, and now I'm plugging in 0.1. Oops. So 0.1. And let's do one more, right? So 0.001. Okay, so something like that. So if I do this, I get 5 divided by 1/10, so it'll be 50. Right, you guys can use a calculator to check it. Okay, so I think we are pretty sure we know what's happening. Let's do that one last substitution. So 0.001. So this is 1,000. Right, so if I do that, if I use a calculator or whatever, so that's gonna be 5,000. Right? So you see what's happening. What's happening? This this limit is equal to infinity, positive infinity. All right, so equals positive infinity. We can keep this as x. All right, so yeah, so this was pretty simple. All right, so let's do the same thing with here, with limit where x approaches 0 from the left. Okay, so again I have 5 plus x over x. Okay, so this time I'm approaching 0 from the left. Alright, so we could technically we could pick the same numbers, but well, opposite numbers, right? So negative 0.25, negative 0.1, and negative 0.01. Alright, so again, right, you guys can use a calculator. We can assume that the numerator will be 5. So I'll have 5, I have that x. So yeah, you see that the solution, the answer will be negative infinity. Okay. Yeah, so this was pretty simple. Let me show you another example, and then I'll give you problems. So example 2. So this one will be a little more difficult, right? And I'll give you problems that are even more difficult. Okay, so we have limit, and I'll just do one. Maybe I'll do the easy one. Okay, so I'm approaching negative 2 from the... let me do, I don't know which one is easy. Let's do from the left. Okay, so that's that, and here I have negative 6. And we have x, x plus 2. Okay, so the same, right? Same idea, the same concept. This time we have negative 2, right? So I'll put negative 2 here. This will be negative 3, negative 1, and this is 0. All right, so we're supposed to be approaching that negative 2 from the left. Okay, so again, right, don't plug numbers that are far away from that negative 2, right? Plug numbers that are close. So what could those numbers be, right? So we could, let's see if I can do this. Maybe. All right, so what could those numbers be? I'm still on, right, so maybe negative 2.2. Okay, maybe negative 2.1, negative 2.001, etc., right? So what is happening? So let me take this and rewrite my function here. So negative 6, and then I have x plus 2. Okay, so I'm plugging in negative 2.2. Alright, so if I do that, this will be a negative number. Right, so I'll put that in a minus there. Now this whole parenthesis is also going to be negative number, right? Because negative, if I take this, right, this, and I'm plugging it here, and negative 2.2 plus 2 is going to be negative 0.2. Okay, so this whole parenthesis is going to be negative. Now I have negative times negative, that's positive. So I have eventually negative divided by positive. So the answer will be negative infinity. Okay, so you guys see that, right? I cannot plug in that negative 2 in for x, right? And I cannot simplify anything. So that is the answer. Yeah, so with positive infinity, with approaching that negative 2 from the right, and I'll be plugging in numbers like positive. Let me show it to you quickly. So 1 point, whatever, 8, right? It's going to be negative as well, right? So I'm here on this side. Okay, negative 1.8, and then negative 1.9, negative 1.99, etc. All right, so if you do that, this is negative, but this will be positive. All right, so we'll be dividing negative number by a negative number. So in that second case, right, when x approaches the negative 2 from the right, I'm getting positive infinity. Okay, so let me give you a couple of problems, and yeah, we'll be done with this section. So I'll practice. So first one, yeah, so limit, and then x approaching 4. Yeah, can you do both? Yeah, so from the right and left, and then the function is x minus 5, x minus 4 squared. So that's the first. The second problem, limit with x approaching 3, and then the function is like this, x minus 1, x plus x minus 2, and then x minus 3, and the last one, okay, so we have a limit x approaching -2, again plus and minus, right, so do both from left and right, and then x minus 4 on the top, and the bottom x plus 2. Okay, yeah, so let's see, don't forget that while you can't take that 4, right, that number c, that number that x approaches to, and you cannot plug it in here, but you can always plug it in here, right, and then as far when you look at the bottom, you're plugging in the numbers that are close to 4, right, from the left and right, so the same thing here. Anyway, yeah, that's it.